Hello, hello. Welcome back to the final talks day of Academy 2021. I'd like to thank everyone who's here. We have 2 tracks going right now. This is room 2. And the start of room 2 will host Volker talking about releasing Android apps, building, optimizing, and deploying release APKs. Volker, would you like to join me up on stage?
Of course. Hello.
It's great to see you. Well, I'd like to remind everyone before we get started, Volker, that this is the final talks day of Academy. We're going to have 4 sessions in this room 2 and join back into room 1 for the final talk at Academy, which will be hosted by Alice, about working in open source or working with KDE professionally. But let's talk about releasing Android apps. So welcome, Volker, and it's so great to see you again.
Thank you, Alison. Hello, everyone. Yeah, we are going to look at how to package, release, and deploy our applications on Android, and specifically the recent work in that area. When talking about Android, I mean both the completely free software, Google free variants like Lineage OS, as well as the proprietary variants, like most prominently the Google Android. From our application point of view, those 2 are essentially the same. We don't use any of the proprietary extensions anyway. And what motivated that recent work is somehow the problem that we have a number of our applications that actually work on Android and would provide value there, but they are simply not available. And in parts that is largely our problem, because we don't have the situation like on Linux where we have distributors taking care of this. In this case, we are the distributor ourselves, which means we have to do all the work. And that work is a bit more than just adding a tag in Git, right? First of all, we need to build actual release packages. They need to be optimized for size, because the target platform is mobile and size and transfer volume is constrained there. We need to build from release tarballs to have the translations included. We end up bundling a whole lot of third-party dependencies, which means we have to look after their licenses as well as the licensing of our own software. We need to have our packages in the corresponding app stores, as side loading on Android is disabled by default and heavily discouraged. So practically, you have to be in the App Store to be available. In order to be in the App Store, we need the application metadata, logos, screenshots, translated description text, and all of that. And if you're looking at all that list, and remember that we have 9 KDE gear releases a year at least, and 12 Plasma mobile gear releases a year, times number of applications in parts times of number of translations, right? That quickly gets out of hand. So we need to automate as much as possible of that in order for it to be sustainable. The current situation, where current refers to early April when I wrote the talk proposal, there is very few of our applications actually available on Android. For example, KDE Connect, Krita, and gcompree. They all use their own custom solution for building, packaging, and distributing, in parts because they have very special requirements, but in other parts simply due due to the lack of a better solution. Next to that, we have the nightly build system on Binary Factory. So there we have about 25 apps that get daily builds based on the latest developments and have those put into a dedicated F-Droid repository. That system is heavily optimized for low maintenance and a low barrier of entry. And that comes at a cost. There is very little there in terms of custom or ability to customize the packages. Dependencies are auto-determined from the dependency metadata. There is no way to customize build flags or select which version or version of a dependency gets included. So that's not ideal for polished release packages. It is based on the Android Docker SDK that we also recommend for local development. And it's using in parts the same tools. So that makes it very easy to use. And the results you see locally are very, very similar to the results you see in that system, which also helps to work with it. And then if you look beyond Android, the standard solution we have for the other platforms there is Craft. And then, of course, there is immediately the question, can we use that for Android as well? That will allow us to reuse all the existing package definitions and build instructions for pretty much all our applications. They're already present for Windows, macOS, and Linux App Image. And not just reuse that and like sharing the entire build definitions going forward, which would be a big plus. Craft is also much more tuned towards building actual packages. So you have a lot more control over what exactly goes into the package. That starts with building from release tables. We get translations. You can apply patches to that if necessary. You can pin dependency versions. You have full control over all the build flags and so on. On the other hand, there is the problem that Craft has no notion of cross-compilation. And that is something we need for Android. Right? We are not building on an Android system. We are building on, say, a Linux system for an Android target. And the other problem is that Craft is used to decide itself what goes into the final package and drive that process, while on Android, that is done by the application build system. About 2 months ago, we nevertheless managed to get that to work by cheating a bit. We work around the cross-compilation problem by assuming that everything that needs to be built for the host system, say mock for Qt or kconfig compiler for frameworks, are already present on the host system. And we can make that assumption because the Android Docker SDK image provides all the host tools already. So the only thing Craft still needs to do is build for Android. And for that, we just pretend towards Craft it is building on Android, and behind its back implement that as cross-compilation. So it doesn't even realize it's doing cross-compilation. And that actually works quite well. For any package that is using a standard build system, that is largely transparent. And especially for our own stuff, the most you usually need to adjust is maybe tweak dependencies a little. Like on Android, you might not want to have a dbus dependency. But that is very straightforward. There is more fun to be had with dependencies that use their own custom build systems. But at least the crucial ones, so the dependencies of Qt and so on, they are already covered and working. And we have that deployed on Binary Factory alongside the existing system for the other platforms. And you can enable Android builds there for your application using exactly the same mechanism. So there's the enabled projects YAML file. You just put your project in there and then select which Android architectures you want to have covered. There's currently 4 of them supported, x86 and ARM, both in 32 and 64 bits. And then your package gets built and it's running through basically the same pipeline that we also have for the existing nightly built system, which means transferring the package to a secure system, getting it signed with the official KDE key, and then put into a separate F-Droid repository for that. So you can immediately test the result on your phone. There's 2 build modes supported, release and nightly. Release builds the latest release tarball and thus also gets you translations included. Nightly builds the latest development from Git. That gives us the option to replace the old nightly build system with that system as well. That will have the advantage that we have unified everything on Craft and we only have a single system to maintain. On the other hand, as I mentioned, the old system has the advantage of having a very low barrier of entry. That isn't the case on the same level for Craft. So there is a bit more complexity to learn in order to get started with this. During the past days, we discussed ways to simplify this and to improve the documentation. So we might get to the point where we can actually replace the old system with the Craft-based nightly builds as well. But that is still under discussion. Okay, so now we have the package built, and it hopefully contains everything we need. That isn't good to go yet, though. The problem is that while there's everything in there we need, there is actually quite a lot more than that in it. If you have ever looked at the nightly build packages we had so far, they are all quite large. So we need to trim them down. And as with any optimization problem, the first thing we need is a way to measure what we are changing. There's 2 useful tools for that in the Android SDK, the APK Analyzer command line tool, and the corresponding UI for that in Android Studio. If you just open one APK in there, you get an overview on which parts contribute how much to the needed space. But more importantly, it's able to compare 2 different APKs of the same application, and then you can nicely see how things changed if you applied some of the following mechanisms to it. And then we get to ways to actually optimize the content. And the first thing to look into is do not install anything you don't need. And that goes both for your application as well as for all of your dependencies. Common example, man pages might be nice to have on a Linux system. They're utterly useless in an APK. So look out for build options to exclude stuff like that. If a dependency doesn't provide them, consider adding them. If it's about stuff that will never be useful on Android, and if not Android, conditional around the install commands might be good enough already. And that anything that isn't installed will never make it into the package. So that is the easiest way. The second thing to look at is do not link against stuff you don't need. And that also is something that goes both for your application and for your dependencies. And that is, or the common offender for that is Qt widgets. That is a fairly large library, and it's something where a lot of other libraries have optional dependencies on it. So just by being present, they end up linking against it. We have meanwhile addressed that for Qt SVG, for Qt quick controls, and for K-notification. That is common dependencies of our applications. Those will no longer drag in Qt widgets. But you might encounter that in other dependencies. And then it's usually a smaller build system change to resolve that. Then the third part to look at is plugins. The way plugins end up in the package is that the build system looks at the Android dependencies XML files of all the libraries you link against. And those files can specify which plugins or which plugin types are supported by those libraries. And then all those plugins get pulled in. The common examples in there for things that you might not need are the QML tooling plugins, some of the more exotic image formats, and the biggest ones usually are additional Qt quick control styles, especially the asset-heavy ones based on images. Fusion, Imagine, and Universal. So excluding those is often useful. The way to do that is using the packaging options exclude list in your build.gradle file. If you do not have a build.gradle file in your application, there's actually a default one shipped with Qt that is being used. So copy that next to your Android manifest and adjust it. And finally, there is a similar exclusion mechanism for asset files. That is basically anything that goes into user share on Linux. So all kinds of data files. And anything you couldn't get rid of in step one, maybe because it's very application specific, is something you can handle here. Say translation catalogs for a dependency where you're sure you're not using the translated messages, then you could remove that in this way. I mean, translation catalogs are usually very small, but they multiply by many, many different languages. So that can be worse. Slight problem with that is that the asset ignore pattern, unlike the plugin ignore pattern, uses a very bizarre and limited syntax and needs to be squeezed in a single line. I have a link to a blog post on the last slide with some more details on that. And all that actually allows you to trim down the package quite a bit. As an example, the itinerary started with around 40 megabytes before all of that without translations. And we are now scratching on 20 megabytes, including translations. There's still more room for improvement there, but that is quite reasonable already. Okay, so now we have the size optimized package. Now we need to get it into the store. And for that, we first need the application metadata. So that is translated descriptions, screenshots, logos, etc. The canonical source for that is the AppStream file that I think most of our applications have, and that are used for numerous other purposes already. The Android toolchain in ECM comes with a script that can convert the AppStream file into the Fastlane format, which is the format that the F-Droid store is consuming directly, and that the Fastlane supply tool uses, which is the tool to talk to the Play Store automatically. You have the ability to customize the output by putting partial Fastlane data into your repository. And then the script will just fill in the gaps of anything not specified there yet. So if you want to have different screenshots for Android, that is easily possible in this way, for example. And this is how this then looks like. On the left, we have the F-Droid app on the phone. On the right, we have the Google Play Store website. The screenshots are taken within English language. If you switch the system language, you also get our translations there. On the F-Droid side, you see this banner graphic. That is something that isn't modeled in AppStream. So that is using this Fastlane customization mechanism to get that into the metadata as well. And everything you see in there is coming through that automatic process. There's no manual entry there. This conversion runs both in local builds and on Binary Factory. So if you look on Binary Factory, you will see next to the APK also a zip file with the generated metadata. So if you want to fine-tune anything in there, you can inspect that both locally and on Binary Factory. Right, and then we need to get this into the app stores. Let's first look at F-Droid. So F-Droid is actually less of a store and much more similar to what you might know from a Linux distribution. The app is more of a package manager, and there are multiple repositories with the packages you can install and update from. There's an official repository provided by F-Droid itself, and there can be arbitrarily many third-party ones. Like I mentioned before, we have a few third-party F-Droid repositories for all the Binary Factory output. Those you would need to add as a user manually, though, so that is not ideal for discoverability. Better would be to be present in the main repository of F-Droid. That, however, requires that F-Droid builds the package themselves. Right? They don't accept random binaries thrown at them, which makes sense from a security and reviewability and reproducibility point of view. Their system, however, is very much built around like the usual Android technology stack, so the Java and Kotlin. If we show up there with 30 C++ libraries that need to be built for multiple architectures, that doesn't really work that well. Nico has managed to do it once for Ktrip, but it is a very lengthy and painful process. So that still requires more work together with the F-Droid people on streamlining this and finding a way how we can manage that more sustainably. As a stopgap measure, we might want to look into getting at least our release repository added by default to the F-Droid client. Then as a user, you still need to set the checkbox to enable that. But at least you don't have to enter the long URL for that. And then we have the other store, Google Play, that has also its own pain points, just in different places. So to get started here, you need a Google account and get that registered with the KDEEV store account. That is something Alesh can help you with. And then you need to once go through the entire manual, the entire setup process manually. That involves filling in a bunch of forms. most of them don't really apply to us. They are about to properly register for all the evil stuff you can do, but we don't want to scam someone out of their money or trick them into online gambling or whatnot. So this is usually just clicking no on all the forms. This process, however, requires review and approval steps from Google, and that can take a day or two. So that process takes time, even if it doesn't take a whole lot of work. Once that is done and everything got approved, we have the ability to automatically interface with the Play Store using the Fastlane supply tool. This isn't deployed on Binary Factory yet. I have a working prototype for the metadata, but that still needs some work because currently it triggers a manual review of the image assets each time we run it, and that takes 1 or 2 days. And if we run that process every 24 hours, we end up with something that just spams Google and will never finish. So that needs a bit more clever scripting to detect if we have changes in the image assets. But the screenshots I showed you earlier, that is already fully filled just by the automatic interface. And that's nice because that means we get translations from the upstream data into the Play Store fully automatic on via Binary Factory eventually. And the second part to look at is automatically uploading the resulting APKs, at least to the beta channel on Play Store. That's possible by the same mechanism, but that also still needs work in terms of automating it. The really unpleasant part is the next bit. Starting in August, the Play Store is set to require AAB packages, at least for new applications. And that has 2 problems. One is we have so far we can't build those packages, and that potentially requires larger changes to how we do that because they include all the different architectures, not just one, and we build them separately. And the second part is it requires handing over your signing key to Google. That's, of course, something we don't want to do for the existing one, as it would compromise the F-Droid repositories. On the other hand, you can't arbitrarily change signing keys because that will break updating existing installations. So that still needs some work in looking into. Yeah, and a few more things to look into going forward. It will, of course, be nice to have more apps and application maintainers participate in this and try the new system. To some extent, that has happened with the Feller brothers applying this to some of the Plasma mobile apps. As I said, there is more we can look into for further minimizing the packages, full static builds, for example, or minifying the QML code. There is the whole discussion that we had in the past few days as well on the QA process and the QA process automation. That also applies to all other platforms. That's something that matters for Android as well, of course. For license compliance, there is some interesting work going on from the KDE NLive people. They're working on extending K-about data and our standard about dialogues to also cover third-party dependencies. That would go a long way in addressing that part. There is the crash reporting feature in the Play Store to look into. Usable crash reports would, of course, good to have. But that will require that we generate the corresponding symbol files and deliver them as well. And then finally, once we have polished release packages available, there is the question: should they cost money in the Play Store? It's a similar discussion than what we had in the past days as well for the Microsoft Store on Windows. Only in the Play Store, of course, not in the free F-Droid store, and in order to support the KDE EV. If you're interested in a topic, we will have had a BOF last Tuesday. And there is the KDE Android Matrix channel and mailing list that you might want to join. Okay, that's it. Do we have any questions?
Yep, we do have questions. Hello, Volker. Thanks for your contribution. I guess that this topic is going to be very, very important for the near future. So, from the questions, the first one is from Fabian. He's asking, have you tried to compile a custom Qt build with disabled feature? For example, -no feature, quick controls to imagine instead of later removing files at the Gradle level?
Yeah, we are doing this to currently still very defensively. I mean, we are stripping out some of the Qt location backends, for example, that way. We are probably also going to enable that for the quick control styles. The problem is that that configuration is shared between all applications. So if we remove something that somebody relies on, that is a problem, right? We initially started with not even having Qt widgets, but that caused trouble for some apps that rely on QAction, which in Qt 5 is still in Qt widget, and only in Qt 6 actually moves to Qt GUI. So we had to bring Qt widget back. So it's a bit about finding the right balance on what can we do generically and which parts need to be per application. We also had the craft BOF yesterday, where Hannah had some good ideas on how we can move even more of that stuff to a generic level and reduce more and more of the stuff that applications need to do individually. So that's certainly a goal, but it requires a bit of a balance.
I see. Okay, the second question for now, there is just another question. Just if you attended the Academy in the first part on Saturday and Sunday, you already know that you need to check the QE widget in the chat room, in the chat room of the talk, to be able to add questions. Or you can also, from time to time, the other chat moderator will link the place, the URL, so where you can add the questions if you have troubles with the widget. The second question is a bit not exactly technical, is where does the banner image, not the application icon, on the Play Store come from?
You mean this one? I mean, this one is, well, I color painted that together from the icon and the KDE icon and put that into the Fastlane override folder. So that's injected in the metadata, as that's something that we don't have in AppStream. That is, I mean, Google Play wants that as well, but I haven't found where it's using that. So far, I've only seen it in F-Droid. The image on Google Play is just a large version of the application icon. That actually also is, it needs to be a very large PNG, something that we don't have in our usual icons. So that might also be something that you actually need to specifically create for Android. But if you have an SVG icon, that is very easy to do.
Okay. In the meantime, we have another question asking about making apps paid in the Play Store. Are you aware that once an app is made available free on the Play Store, you can change it to being paid, or only by making a new entry?
Yeah, as I said, I mean, this is an ongoing discussions on how we want to handle that at all. There were various possible ideas with having a free version and a for pay version, or having the pay as an additional upgrade, or yeah, I also think we will end up experimenting with different models for the different apps and see what works, right? I mean, the monetization of this is a nice to have feature for getting more money into KDEV, but it's not something that is absolutely crucial that we need to get right from the beginning. But yeah, I'm aware that there's certain restrictions on the App Store, and they keep changing, and we'll need to work with this.
Okay, thanks. So I don't see other questions coming. So if you're interested, where can people find you? I guess, well, apart from going back in time, as someone was suggesting on the chat, and go to the BOF.
Right. Yeah, I think the best place for that is the KDE Android Matrix channel and the KDE Android mailing list. There, the people involved hang out, right? Myself included.
Okay. So thanks again for this effort, and we're going to have a short break, and we'll start in 6 minutes with the next speaker.
Okay, thank you.
Hello, Lars. Welcome. We are still we still have 2 minutes before the official start, so it's a good time to ensure your setup is fine. But it seems everything is fine.
Yes. Hi, Luigi, and good evening. I think
morning.
everything's fine, except that it might be getting slightly warm in this room here. This is my office, and I have the evening sun directly going in.
I see. Specifically, so here in Sicily, it's really hot these days. It's the last week was kind of crazy. That's the usual. I mean, it's not unusual to have the heat wave at the end of June, beginning of July. So I'm not sure, but I've heard in the rest of Europe is a bit different. So
yeah, but Norway is fine. 22 degrees or something like that. It's just this room, the office, that gets really hot in the evenings.
Okay, I see. Oh well. But on the other hand, in the winter, it's better.
Well, and then it's dark and cold. Yes.
Oh, right. I forget that part. Yeah, that's. Okay, we still have 1 minute to go. So just a general reminder for people who are following this session. As usual, you will be able to ask questions if there will be time from the Q&A widgets that you will see soon from the room inside the room, or you will see also the link being shared. Okay, the link. Okay, the QA widgets is already there, so you can already open it, have it ready if you want, or it will be the link will be shared in the chat room. And after, we are going to have other 3 sessions in this room, and then we will all move to room 1 for the final part of this wonderful academy. Hopefully next year will be in presence, but I think we did a good job for given the current circumstances. Okay, I guess we are perfectly on time, so we can start. And thanks, Lars. Lars is going to, of course, introduce us the Qt6 new features and roadmap.
Yes, thanks, Luigi, and welcome everybody. So I'm going to talk and spend the next around 30 minutes, maybe a few more, talking just about recapping Qt6, what led us there, what motivated us to do Qt6, where we are with Qt6 1, and a little bit of an outlook into 2.6 and slightly beyond. So let's get going. To start with, when we're doing a major version update, it's always important that we think a bit about what's really the important thing in the tooling we're doing. What is the thing that's actually driving us? And for Qt, it has always been, and for all the 20 years or more than 20 years I've been working with Qt, it's been about making life easy for developers, making development of applications, cross-platform applications, and then embedded devices fun and easy. Simplify that. That's the thing that has been driving us all along. And for Qt6, we wanted to take the next step there and do some more changes that further improve this. So let's have a little bit of a look into Qt6 and what has been motivating us there, things that we've been doing. But before we go there, let's take a little bit of a high-level view. For Qt6, we had a couple of high-level goals and fixing certain architectural limitations that we have discovered over the years in Qt 5. We wanted to improve performance in quite a few places. A very important topic for us has been to clean our house a little bit, get rid of legacy APIs, old code, things that we don't want to use or maintain anymore. We wanted to try to see what we can do with package management support and have that better supported within Qt. I don't think we're quite there yet with Qt 6, but it is still something that's on our agenda. Make the core product, the core of Qt, a bit smaller and more modular, maybe also allowing us to handle add-ons slightly in a different way. But then, of course, also very, very importantly, that we are keeping the compatibility with Qt 5 as much as is possible. We've also have a couple of important high-level values that we need to keep up, and that's our users value. This is the cross-platform nature of Qt, that we are basically running on every desktop operating system out there, every mobile operating system, and a wide variety of embedded systems. the maintainability, compatibility, that Qt actually takes the burden of bringing your application to the next version of a platform away from you, that we're trying to take that, and that the code that you're writing is actually generically very maintainable over time. Scalability, you can go from very low-end embedded systems to complex high-end desktop applications, connected applications that span multiple devices, multiple large systems like that. The APIs and whatever we're having on the tooling side should be intuitive and easy to use. We're proud of the documentation that we're having, and we want to keep it that way. Having a world-class documentation is really, really important. And the thing that got over the last years more and more important for us is also the tooling. So a couple of high-level goals, as I said, cleaning up our code base and our architecture, and not new features. That was the main goal for Qt 6.0 and is still the main goal for 6.1 and 6.2. We're not focusing that much on bringing tons of new features to you at this point in time, but rather clean up what we have and prepare it for the future. Nevertheless, you'll see some pretty cool stuff also already in 6.0 and more of that coming in 6.1 and 6.2. Compatibility, as I mentioned before, is really, really important for us. And we have a very large user base out there. KDE is one of the big projects that's using Qt, but we have so many other people. There are billions of lines of code that are written against Qt. And that means we need to make it easy to bring all that code over from Qt 5 over to Qt 6. So we wanted to make sure that Qt 6 is as source compatible as we can with Qt 5. There's still nevertheless some porting that will be required, and I think some of you who have been working on that already within KDE have maybe seen a bit of that. We have removed all the deprecated functionality that goes back to the house cleaning that we wanted to do and preparing ourselves for the future, which means you'll have to clean up certain pieces, but most of that can be done on top of 5.15, enabling deprecation warnings. Will get you a long way there. And those changes really prepare us for now for the next years to come, so that we can hopefully also Qt 6 can have a rather long lifetime. Let's have a little bit of a look at the large architectural changes we've been doing for Qt 6. The first one was to move over to C++ 17. That has been an important topic for us. We wanted to move along with the C++ standard and make sure that we can also use newer features that are available in those new C++ versions. We've moved to C++ 11 with Qt 5.6. Now was the time to take the next big step and also start using that in our code, in our own code, but also modernizing some of our APIs to, at least to some extent where possible, to make use of modern C++ features. Let's start off at the low end, what we've been doing on our containers. A large amount of work has gone into that area. A big thing for us was to look at QList and QVector, the two containers that were doing similar things. There were some implementation issues with QList. Many of you might be aware of them. And we've now had a close look at those, and in the end decided to bring those together to have one class in Qt for doing list-like operations. And QVector nowadays is an alias to QList. We've introduced 64-bit support for all the containers. So they're all using Qt size type now to store size-related and index-related information, meaning you can have more than 2 billion items in the container, something that was requested for a very long time from many of our users. QHash and QMap got completely rewritten. QMap basically is now using standard map underneath behind the scenes and can actually be converted at or moved to and from a standard container. Q-hash, we have gone a different route and we implemented it on completely on our own. I'll show you on the next slide a little bit why. And then we went in and filled lots of API gaps that we Qt containers had towards the standard containers. Make sure we can consistently use move operations, emplace, ranges, and initializer lists, and other things. So with Q-hash, we actually went back and did our own implementation. And here's a little bit of the reason why. We had a look at standard unordered map and whether that could be a solution to base ourselves on top of that. But what we found when we did some benchmarking and some measurements was that standard unordered map was performing rather similar to Q-hash and Qt5. It was a bit better in terms of memory usage and consumption, but there are other hash tables out there who can do a lot better. And we went in and looked at that and then implemented a hash table that gives a very good compromise or gives us very good performance also for large hash tables and a much, much lower memory consumption than what we had with Q-hash and Qt5. We were finished also another item that was only 80% done in Qt5, and that was Unicode handling and all our string classes. In Qt6 now, all text handling is Unicode based. We assume basically UTF-8 for data that we're reading in by default and UTF-16 for all our internal data that we're storing. Our source code, for source code, we by default also assume UTF-8. And we've cleaned up all our string-related classes to make sure that we have now a consistent set where we added QUTF-8 string view for UTF-8 encoded data and the view into UTF-8 encoded data. We had QString view already and completed that one, made it mirror all of the read-only API of QString and deprecated certain APIs such as QString-ref. Finally, we also took the step and moved the legacy encoding support out of Qt core. So QText codec is not part of Qt core anymore. We have a QString converter classes that can do Unicode conversions plus Latin 1 and local 8-bit. A second big topic for us was the support of bindings. Bindings are a concept that came and that we introduced in QML and Qt Quick. And that is probably the feature that made Qt Quick really, really successful over the last years. Having the ability to bind arbitrary expressions to properties and making sure the properties get automatically updated whenever a dependency, something in the expression changes, has proven to be extremely powerful. And with Qt6, we wanted to bring that support down to Qt6 to make it available to all of Qt and bring it to C++. So that when you're doing C++ development, you can use bindings the same way as you can use them in Qt Quick. Wanted to make sure that we have a seamless integration there with QObject and make it a simple extension of the existing property system. In addition, we also introduced a new QProperty class, which supports bindable properties also outside of QObject. Here's a simple example in Qt Quick. You can easily, if you define, for example, a rectangle, and it has a property width, height, and border, and you can easily bind here the width to the height. So when you change the width, the height will get adjusted. It's actually a square using those bindings, and it has a border that is 10% of the height and thus 10% of the width. And those relationships always hold. In Qt6, you can do the same thing in C++. And the code is rather similar. So we have a rectangle as a struct with 3 properties, width, height, and border. And then you can set up in the constructor, you can set up your bindings where you bind the width to the height to the width and the border to 10% of the height. The second really big change and new feature for us was redoing our graphics architecture. This is probably the one area in Qt where we've done a lot of work. Apart from Qt Core and the changes there, this is probably the area that has received most work there. And the reason for that is that the world has changed significantly since we introduced Qt 5 in this area. When we did Qt 5.0, OpenGL was the cross-platform API that you could use for 3D and hardware-accelerated graphics. It was pretty much supported everywhere, even though it was to some extent a little bit of a second-class citizen on Windows. It was still supported there, and you could get good OpenGL drivers on Windows. But the world has changed over the last couple of years. Apple introduced Metal as their new 3D graphics API, has gone so far as to deprecate OpenGL. Vulkan has come up by the Kronos Group as a successor, and Microsoft is focusing more and more of their work also on Direct 3D. So it was time for us to change that and introduce something that helps take this away, because now we're having a situation where there are many different APIs, and for us as a cross-platform framework, of course, the job is then to see how we can take that burden away from the application developer. So we added a thin layer on top of those graphics API called the Qt Rendering Hardware Interface, and built Qt Quick, the scene graph, Qt Quick 2D and 3D on top of that. In addition, we introduced a new module called Qt Shader Tools to be able to handle shaders in a cross-platform way. The rendering hardware interface is actually an abstraction layer, a very thin abstraction layer for 3D graphics APIs, covering OpenGL, Metal, Direct 3D, and Vulkan. And it abstracts all the graphical objects that we need, materials, meshes, shaders, and so on. For the moment, it's an internal API tuned towards the needs of Qt. We are considering making parts of that public also in the long term, probably QPA style, so that we will not guarantee full compatibility between minor Qt versions, but there is certainly a need for our users to also be able to integrate with the rendering hardware interface in the future. But for now, it's an internal API. Integrates with our platform and the Windows system abstraction layers, and Qt Quick 3D with 6.2 also multimedia and other modules, also Qt 3D, are now fully ported to using that rendering hardware interface. Qt Shader Tools is the complementing module that we need to be able to do that. It's there to support cross-platform shaders. The shading languages differ between the different graphics APIs, between Metal, OpenGL, Vulkan, and Direct 3D. But with Qt Shader Tools, you can write the shader once in a cross-platform GLSL or in a Vulkan-style GLSL, and then we can recompile it to all the graphics APIs, both at build time and also dynamically at runtime. What's important to remember here is that Qt 6 now uses the native graphics API of each operating system. So whatever the graphics API is that your operating uses, we're using it by default. So we'll be using Metal on macOS, Direct 3D on Windows, OpenGL or Vulkan on Linux, and so on. This is really important and make sure that we can get the best possible support on all of those different on all the different operating systems. Qt Quick 3D is a module that we introduced in Qt 5.14, 5.15, but it has received a lot of changes and a lot of good things in Qt 6. We're now basically working on one combined scene graph for both 2D and 3D in Qt Quick, which means you can very efficiently combine 2D and 3D in one scene in your UI and embed them into each other. We've extended and improved the support for PBR materials significantly, and also made sure that we can easily import GLTF where we support the full base spec and most of the common extensions. Quick 3D has also gained a lot of new features, like a 3D particle system where you can do really cool animated 3D effects, instanced rendering in case you need millions of objects in your scene, and also things like mesh morphing animations are now supported. So you can easily connect that and hook that up in QML to the state changes of your user interface. Finally, we've been pushing for better theming and styling of the Qt Quick controls. Qt Quick controls, as we had them in Qt 5.14, 5.15, were not really stylable. There was a little bit of some theming support using pix maps, but they didn't use the native style of the underlying operating system. That's something we fixed now with Qt 6, and we have now native look and feel for Qt Quick controls on macOS, Windows, and Linux. We're also planning on extending that into the mobile platforms now moving forward. And here, the longer-term goal for us is, of course, also to make sure that Qt Quick becomes something that you can fully use also on desktop and mobile, if you want it, even if you want to do native-looking user interfaces. So we will be working on extending also the feature set of Qt 6 to cover those things. The reason here is also that Qt Quick is much more suited to modern, fluid, animated user interfaces than what we can do with Qt widgets. For everybody who has tried to implement animations within Qt widgets knows that this is a rather difficult job to do. It's tedious, error-prone work. Qt Quick makes that a lot easier, and we want to make sure that all of our users can benefit from that, also on desktop and the mobile platforms. We worked the pointer event handling, touch event, mouse event, tablet events, and unified those with one common base class called QPointer event. The advantage here is that, and it solves the problem that we had before when in certain complex controls and use cases, it was really, really difficult to get all the use cases working with different events there. So for example, a touch-enabled controls inside a clickable, there were always quirks with that. And we can do that much better now with pointer events. In addition, we're also now tracking the input device's history of the event points, allowing you to be able to use that extended information in many use cases. As I mentioned before, another big topic for us is, of course, also the tooling around Qt, the developer experience. Qt Creator as the main developer tools is something that we've spent a lot of time improving on improving. And the developer tooling, of course, fully supports Qt 6 nowadays. We have wizards for Qt 6 compliance projects. You can inspect all the Qt Quick types in the debugger. We know about the editor knows about the new QML and C++ language features. And of course, you also have inline access to the documentation and examples. We've done also a lot of work on improving the C++ support, the generic C++ support in Qt Creator, with new and improved refactoring tools. We moved the Clang code model up to Clang 11 and have a much tighter integration now of Clazy and Clang Tidy. And finally did also lots of other smaller changes just to improve that experience. And finally, of course, also in Qt Creator, a vastly improved CMake support. We're having that there. A lot of the improvements come through the work that we've been doing, bringing Qt over and porting Qt to use CMake as its native build system, improving a lot of the CMake support for Qt also upstream in the CMake project, and then also doing that integration into the tooling and Qt Creator. There's a second big tool that we're doing a lot of work on, that's on the designer experience, is Qt Design Studio. Qt Design Studio is a tool that's there to graphically create user interfaces and do all the UI work in a graphical tool. We've done a lot of work there to improve that. So one of the goals for us when we moved over to Qt 6 was to unify the design tooling. In Qt 5, we still had Qt 3D Studio as a separate tool for doing 3D UI design. It was also using a language that was different from QML. We've unified all of that. It's all built on top around QML as the programming language and this one unified design tool with Qt 3D Studio. You can now mix 2D and 3D content seamlessly there. Doing a lot of work to improve that further. One of the goals for us is here with Design Studio is to improve the interoperability with Qt Creator. Qt Design Studio is in many ways Qt Creator. It's using the same application shell around it. It is basically just having somewhat different plugins and a different selection of plugins and some changes to the UI compared to Qt Creator. So that's going to happen, and we have still a bit of work to do on that front. And we, of course, have a big goal of making sure that all our UI features in Qt Quick and Qt Quick 3D are toolable. Now, also advanced things like particles, skeletal animations, and that we have a lot of low-code features available there for the developers and designers so that you can visually program a lot of the UI logic. Things like shader programming tools, wireframe tools for 2D shapes and paths, all of those kind of things are things that we want to add to Qt Design Studio. Beyond Qt 6.1, what's happening there? What are we working on right now? As you probably know, Qt 6.2 has just recently gone into feature freeze, and most of the work has been there focused around putting the remaining add-ons to Qt 6. Connectivity, remote objects. With 6.1, we had already charts and data visualization, many others. All of those are coming back in 6.2, and 6.2 should be, to the largest extent, feature complete, in meaning having the same feature set as Qt 5.15. There's a lot of bug fixing we have been doing and working on, and making sure that we have stability and maturity. 6.2 will be the first long-term supported release for the on the commercial side as well. So we want to make sure it's as good as possible. And of course, also make sure that the development targets then again match what we had in Qt 5 by adding integrity, QNX, WebAssembly, and more embedded hardware platforms. A larger change that's happening with Qt 6 is that we're getting a completely rewritten Qt Multimedia. I've been myself working a lot on that module with an easier to use API and hopefully a consistent cross-platform feature set. Qt Multimedia has been, let's say, a module that we were never really happy with during the Qt 5 lifetime. And I hope that we can now with Qt 6 get something that's really good and easy to use, and that also our users will be happy with. Qt Web Engine will live a little bit more its own life. In Qt 6, we will be working on decoupling it from the Qt release cycles, allowing it to do faster releases. Basically always base it on top of the latest, most secure Chromium, and be able to use that latest web engine version with multiple Qt versions. And of course, finally, also Qt for Python is something that we're bringing along all the way and where we want to support everything there. So here's the list of the supported modules that we had. As you can see, we already had quite a lot of things available in Qt 6.0. In 6.1, we added another 7-8 modules. And with 6.2, most of the remaining modules that we had in Qt 5 are then available as well. As you see, Bluetooth, multimedia, NFC, remote objects, serial bus, you name it. On the platform side, in Qt 6.1, we're basically supporting Windows 10, Mac OS 11 on Intel hardware, and Linux as development hosts, and then have also Windows 10, Mac OS 10.14 and newer, Linux desktop and embedded as target environments on the mobile side, Android and iOS. And then finally, we're having on the embedded side QNX and Integrity as tech previews. For 6.2, This is improving slightly. And we're then also supporting Mac OS 11 on ARM, on Apple Silicon fully, both as a development host and a target environment. We're fully supporting then QNX and Integrity, and we're bringing WebAssembly back as well. Okay, and here finally, just to give you an overview over the release schedule, Qt 6.1 has been released in May. We're working on Qt 6.2 and hope to have it out in September this year. And then if you look closely, you can see that we're adjusting our release schedule slightly. We're continuing to have biannual releases every 6 months, but we're shifting them forward a little bit. We used to have them in usually November, December, and May, just before Christmas and just before the summer vacation break. And we're now shifting that more towards spring and autumn with March and September. That is our long-term goal. Okay, and that brings me to the end of my presentation here. Thank you very much for listening, and I think I'm happy to answer as many questions as possible in the remaining 10 minutes.
Thank you, Lars. There is a lot of work ongoing, and when you have to deal with a base library or base framework, better, like Qt, so it's always complicated when you have to do breaking changes. But we have a lot of questions, so let's start. So from the Nicholas asks, we want wide codec support in KDE to handle arbitrary data from the internet. Any plans for bringing that back in the future in some form?
So first of all, it's not completely gone. The existing Qt codec support is there in the Qt 5 compat library, so you still have that available. The plan for me for the longer term is, or the change was twofold actually. One of them was that I was never really happy with the Qt codec API, and QString converter, QString encoder, decoder has a much better API in that respect. For the long term, I think that, and I've designed QString encoder and decoder in a way that we can extend it and basically add a little bit of a plugin infrastructure there to it so that it can support other encodings as well. Probably just using ICU as a backend there, and with the plugin would solve most of those issues. Hasn't happened yet for 6.2. It's a little bit on the backlog right now because it's not that urgent for most people. There are very few applications that need the full codec support these days. It's basically an email application. When you're doing that, there might be still a little bit the web browsers, but they're anyway doing their own stuff. And then it's maybe a text editor, and that's where it ends. So it's sort of a little bit that corner case use case these days. If you look at how much of the text and the data out there is Unicode encoded these days.
Yeah, the compatibility sometimes is important. So another very voted question from David is: would it be possible to create our own new style, quick control style? For us, Fusion is not really native.
I understand that Fusion is not really native for KDE. I think it's possible. I haven't actually looked into the architecture. And I mean, of course, we can certainly consider how to do that, whether you want to do that as a plugin in KDE or contribute it upstream to Qt. Both of those are actually should be possible. And if there's hindrances in the way, we can see what we can do to enable that. Shawn is also talking, I think, later on here and ask him. I think he knows much more about the system than I do.
Okay. There are some questions. I'm going to combine 3 questions about modules which are not in the list. People are asking especially about Qt Speech, Qt Location, and about Qt Gamepad, if there are plans for those 3.
Yes. So Qt Gamepad, let's start with that one, is basically, I think we just haven't published it. It does compile against Qt 6. So if you pull the code from Git, from Code Review, from Garrett, it just, as far as I know, it works against Qt 6. Not currently supported. We're not quite sure what to do about the module in the longer term, but it is there, the code's there, and it should work. Qt location is something that will come after 6.2, and we will be working on bringing that back. And then Qt speech has always been a difficult module for us as well. Text to speech and then speech recognition, we were never really happy with it, so we're not quite sure yet what we're going to do about it, but any feedback in that area would certainly be welcome. What people need. I would really like to hear what people want from the module, what they need.
Okay. I have another Qt quick controls question, but let's try it anyway. Maybe it will be for the next speakers. But what do you define as native look and feel for Qt quick controls on Linux?
Currently, we're using Fusion there, and the question is, what is the native look and feel? Because yeah, KDE has been using the Qt styling mechanism to define its own things. GNOME has been doing something else. It has always been a little bit of a mess, and that makes it somewhat difficult. But as said, I think Shawn might also be able to answer a bit better there what we can or can't do.
So be ready for the next talk, people. So, okay, the next question is on the graphics side. So Windows also supports Vulkan, and sometimes you get better performance by choosing one or the other. I guess DirectX is the other. Can you somehow manually choose which graphics API is being used for a certain platform?
Yes, you can. There's an environment variable you can set to choose the platform. So you can do that just by setting an environment variable, and it'll use the one that you want. Of course, you'll have to be a bit careful if you yourself use certain graphics APIs directly. Then you have to make sure that those match. But other than that, you can just do that.
We have another short but technical question. So why Q size type instead of size T?
Because we've had a long discussion around that one, and the problem is that we've always used signed integers for our indices in all our containers. Also partially because sometimes you could use negative indices to indicate that you're coming from the end. Now, size itself of a container can only be positive. I agree, but those indices should be the same type, and so we had to choose a signed integer to keep compatibility. It would have broken. Using a unsigned version would have broken a lot of existing code out there, much more than we would have been able to, than we wanted to. The second argument was a bit that also many people outside the C, in the wider C++ community think that signed is actually the better type, or would be the better type for doing those things. It just causes less trouble in many other areas.
Okay, and I guess the final question, we're really almost out of time. It's the Qt gamepad I was asking before. There is the question is a bit more detailed, is a bit more specialized than that. So the question is really, if Qt gamepad support is done, any plan for managing gamepad events in the future?
As said, we'll have to see what we do with Qt gamepad first and how to handle that. There's certainly some work ongoing also, because we are looking into areas like with Qt Quick 3D, how can we extend that with VR support and those kind of things. And then those kind of game controllers fall in a bit more naturally also in terms of how things that you might want to use to control your user interface then. So we'll have to see, but that's work that's ongoing. I'm not sure exactly what the plans are, but there's probably after 6.3 something to look into.
Okay, I don't see any other question, and in fact the time is it's basically running out. So Lars, thanks a lot for this presentation. Thanks a lot for all the work going for Qt, and we will hear again about Qt in the next talks, but thanks again. So a bit round of virtual applause, unfortunately only virtual this point for you.
That's fine. Well, thank you very much for listening, everybody, and have a good remaining, couple of hours of Academy and a nice weekend, everybody.
Thank you. We will start again in 2 minutes. Hello again. We're going to start in a minute. The next presentation, as you can see, this is the Qt track. Remember that you can always ask questions using the widgets in the that you can find in your matrix room, or in the links that will be shared soon in the room if you have troubles accessing that. Okay. Hello, Shawn.
Yeah, hi.
So, welcome. So I understand you have a video, and then you will be around to answer questions later.
Yeah, since I'm going to play a video, I guess I can answer questions at the same time in theory.
That may make things a bit complicated, but
well, yeah,
okay.
Just in chat, but yeah.
Okay, so do you have the instructions for starting the video?
Yep.
Okay.
Hi, this is Shawn Rutledge from the Qt Company, here to talk to you about...
Happy listening.
Okay, so should I start it? Yep. How to develop interactive UIs in Qt Quick 3D, which is just now becoming a possibility. I've been a Qt developer since about 2004, joined the Qt Company in 2011, and these are some other things that I've worked on during those times. I'll be going through different scenarios in which you might be able to use Qt Quick 3D for some sort of interactive application. First, some disclaimers. I'm not on the graphics team, I'm not a gamer, and there's a lot of things I don't understand yet about how 3D rendering is done internally, but as the Qt Quick maintainer, I wanted to make sure that the interactive aspects work similarly in Qt Quick 3D as they do in Qt Quick, so that you don't have to completely start over with different QML types for handling mouse and touch events and things like that. Also, this presentation depends on some forward-looking features that we haven't shipped yet. If you want to reproduce my demos, you can apply these 2 patches and you should be able to. So maybe you want to think a little bit about what applications you have in mind where you could actually use Qt Quick 3D. Surely it's useful for other things besides games, right? But let's start by showing the runtime loader, which is one way of loading a model. And I'm loading a GLTF model here, which I downloaded from the Smithsonian. GLTF is an open format, and they've decided that they're going to use it for digitizing a lot of format. And they've decided that they're going to use it for digitizing a lot of the items in the museum collection. So this is the Apollo command module, which was in orbit around the moon and came back to Earth afterwards. At least I think it's the original, or maybe it was a spare, I'm not sure. So I downloaded this model. I'm simply loading it with the runtime loader, and well, you see that the runtime loader is there. And then at the bottom I have a file dialog, and on accepted I set the loader source to the URL that was chosen from the file dialog. And that's really all there is to it, and the rest of it has to do with navigation. There's a wheel handler, a drag handler with the middle button that I can pan around, and the WASD controller is what you usually use for game navigation, where you use the keyboard to walk around, and also you can use the mouse to pan around the scene. When you're working with Qt Quick 3D, these are the most common QML types that you'll encounter. Object 3D is the base class, implements QObject. Then node has position, rotation, scale. It's abstract, but it can be instantiated and it can be used as a container. So a node can contain any number of other nodes. Another subclass is the model, which has geometry and materials. This pickable property is important for making the model interactive if you want to add any interactive content as children of it. And then you have lights, camera. The runtime loader is the one I just showed that was also putting geometry into the scene. Then we have materials. Principled material and default material have the same shader implementation, but they have different properties. Default material has the specular and translucency. Principled material is a more modern PBR approach where it has metalness. Custom material is also similar, but it does allow you to provide your own shaders if you don't want to use the default ones. So you've got a 3D scene and you want to show it. Then you need View 3D. That's a 2D viewport into the 3D scene. It allows you to specify the camera. Skybox typically would be an environment that you would use, and that is an item. So you actually use this to embed it into a ordinary 2D Qt Quick scene. But you're not usually going to write all of that from scratch, right? You might want to start with a modeling tool for creating the 3D objects. The best of the free software for modeling is Blender. It's really worth your time to try to learn that, even though the UI is a bit complicated. It's gotten better in recent years and more organized, easier to work with. But I come from the 3D printing background, so I've been using OpenSCAD a lot. And OpenSCAD is only able to output an STL file, which is just a bunch of triangles. It's just a mesh. And so an STL file can be imported into Qt Quick. I'll tell you how, but you're not able to apply textures to it, or at least not without further modification. That's a nice declarative way to work if you like writing code instead of graphically manipulating things. Then OpenSCAD is fun to work with, but it has its limitations. FreeCAD I haven't had very much success with so far, but it's able to export GLTF in theory. And then you have the commercial tools, Maya, 3D Studio Max, and a bunch of others to choose from. Because Qt Quick 3D is a real-time renderer, our favorite format is GLTF because it was designed for that, and we're eventually going to be able to support all the features of GLTF. STL, like I said, it has its limitations when it comes to applying materials to the result, although you can apply a color and the glossiness and so forth. It's fine to use default material or principled material with STL. Then there's Collada, FVX, and Wavefront OBJ. Those are typically used as interchange formats between the different modeling tools, and they have a lot of features. And Qt is not ever probably going to be able to support all of those features because they're not appropriate for a real-time rendering. So when it comes in to import these different kinds of assets into your scene, I showed you the runtime loader already, and there's also another choice, which is Balsam. That uses our asset import module, which consists of the asset import manager, and then there's a virtual base class for the asset importers, and then we have two subclasses so far. One of them uses ASIMP, which is a third-party asset importer library. Qt 3D Studio is obsolete, but if you've been using it so far to create models, then you'll be able to import them with this UIP importer. So anyway, there's a command line tool called Balsam, and it can read any of these formats and output a mesh file, which is a Qt-specific way of storing meshes, and also the QML for the entire scene. So what you'll get out is typically a node as your root object, and then models and materials and stuff inside there. And you just need to create the View 3D to embed it into your 2D scene. There's also Balsam UI, which is just a widget application that provides checkboxes for all the command line options. So that's one way to work. Another way to work is to use Qt Design Studio, which is our commercial-only tool. In Qt Creator 5, there's going to be a pretty decent 3D design mode built in. So the ultimate goal is that Design Studio will be able to orchestrate all of this stuff so that designers that are not programmers will be able to import it and create the QML scenes, and then they can hand it over to the kind of people who add the interactive functionality to it. If you've been using custom material and writing your own shaders, then probably you want to use ShaderGen to pre-compile the shaders into Spear, which is standard portable intermediate representation, and that makes it more suited for fast runtime loading. But that's an optional step. We're perfectly capable of loading shaders at runtime. So the typical workflow for creating 3D interactive content is that you're going to start with a modeling tool to create your 3D objects and manipulate existing 3D objects that you're able to download, probably Blender, but at any rate you need to choose modeling tools that are able to export GLTF, because that's the format that we support best for importing into Qt Quick. And then you probably can use Balsam on the command line to generate your QML if you're not using Creator or Design Studio for that. And then you just need to create your View 3D and the rest of your 2D UI. And that's basically it. So I mentioned that Creator is going to be having a design mode, and this is what it looks like. I actually imported a model, which you'll be seeing later on. Okay, so let's talk about the most basic use case. If you have a 3D application, you might want to incorporate some sort of a 2D UI into there. And I've simply declared a BusyBox 2D item inside a node. And so what this does is it creates a 2D subscene inside the 3D scene. You'll see that if I use the slider to change the rotation, now I've got a 3D rotating cube over here, and that actually pokes through. BusyBox has a particular size, of course, in pixels, but it's on an infinite plane, and I have a 2D particle system inside there, so you can see that it's filling up the entire space on that plane when the particles are emitted. It's 1024 by 480. This is a 4K screen, and you can actually see that that's taking up about a quarter of my screen width. Another way to use it is to have textures mapped onto 3D objects. So in this case, I've got a node which actually wasn't really necessary. I could have just had my model directly in the View 3D. You know, there's built-in types like cube, sphere, cylinder, and rectangle. I have a model which is a cube and a default material. The diffuse map, meaning the diffuse color, is a texture, and inside there I declare this BusyBox. So this is actually creating a 2D item, and I positioned it in such a way that it goes mostly off screen, and I left 20 pixels showing on the screen just so you can see that that's actually, you see I move my cursor, it hovers, and you see the little orange ball moving around in the 3D scene as well. And that basically shows you that the 2D item is a separate thing, and we're just grabbing a texture from that and mapping it onto the surface of the cube. So the way that works is you set layer enabled true, and that makes a texture available. And then we set the texture size to 512 by 512 so that we get reasonable resolution in 3D. So you have some control over that. You can either save memory or you can make it really high res. The cube built-in type has texture coordinates, meaning UV coordinates, which go from 0 to 1 on each face of the cube. And so the result is that the scene texture actually gets mapped onto each face of the cube at the same time. Now, if I hold down a button, you can see that the button is pressed in all of them at the same time, because this is really only one 2D subscene, just mapped onto all the faces of the cube. And in addition to pressing buttons, you can also edit the text as a nice alternative to eating it. Okay, let's talk about event delivery a little bit. So in this scenario, we're going to say that the mouse is being pressed, and a QPA mouse event comes into QGUI application into process mouse event, and of course we're going to construct a mouse event and deliver it. QGUI application looks for a top-level window to deliver it to, so that'll be my Qt Quick top-level window, which in this case is the entire presentation. So Qt Quick window, its event method gets called. It used to be that Qt Quick window was actually doing the delivery of the event entirely itself, but the new thing in 6.1 is that we have a class called Qt Quick Delivery Agent, which is doing that now. And the reason is because of these 2D subscenes. It's not possible to have the window know about all of that. QQuick window now has its own QQuick delivery agent by default, and that is simply all of the delivery-related code that was in QQuick window. So it was a simple refactoring, or at least that's how it started. QQuick window was an enormous class anyway, so it felt really good to move all of that code out into another class. So the QQuick window is going to forward all of the input events to the delivery agent, and then it does a bunch of internal processing, and eventually it finds the 3D viewport, which is our top-level item. It calls event on that. And then View3D viewport does internal pick, which is a function that does hit testing on the 3D model. Basically, it's shooting a virtual array down into the scene from your mouse position, and it's finding the first 3D object that it hits. It finds the 3D position and world coordinates and the 3D position relative to the model itself. And then it notices that this cube that we hit has a 2D subscene as its diffuse map. And so that's how it discovers the subscene. But let's just imagine that there is a tap handler on the cube. And so the 3D viewport is going to directly try to deliver the pointer event to that handler. This is the feature that's not actually implemented in 6.2 yet. What I'm proposing is that it'll be possible to install handlers directly on 3D models. And so if the viewport discovers that that has happened, then it's going to call set model position and set world position on the handler, and that in turn stores this in the handler point class so that your handler in QML will be able to see those world and object positions in 3D. And then it's going to call handle pointer event on the handler, can react in QML, and the tap handler adds itself as a passive grabber on press because it wants to see the move events later on. So it calls add passive grabber on mouse event, and that in turn calls add passive grabber on the pointing device, and then that adds to the passive grabbers list in the event point data object, and that'll emit a grab change signal which is connected to the delivery agent. The delivery agent then wants it to be remembered that this was the delivery agent that caused this particular grab to happen, because that means subsequent mouse moves need to be delivered the same way. So it calls passive grabbers context append itself. The passive grabbers is a list of handlers that are passively grabbing, and the passive grabbers context is a parallel list of delivery agents that are responsible for dealing with that. So those have to be updated together. Okay, the next thing that happens is we've already discovered that there is a 2D subscene, and so we call event on a second delivery agent, which has been created to handle that subscene. And then let's say that inside that 2D subscene we have an item which is able to handle events itself, but it also has a drag handler on the item. So the first thing it's going to do, because we have a rule that handlers go first, it's going to ask, does any pointer handler want this event? And it discovers the drag handler, which says, yes, I do want the event. So then it delivers the pointer event to the drag handler, and the drag handler also wants to add itself as a passive grabber, so it calls add passive grabber on the mouse event. The result is like it was before. It will be appended to the passive grabbers list in the event point data, and the signal will be emitted. The subscene delivery agent is going to add itself as the context for that particular passive grab. Next, we deliver the event to the item itself because it's one of these old-fashioned items. This legacy logic that we have says that if the item allows the event to remain accepted, then that means that it wants an This legacy logic that we have says that if the item allows the event to remain accepted, this legacy logic that we have says that if the item allows the event to remain accepted, then that means that it wants an exclusive grab. So the delivery agent is now going to set an exclusive grabber to that item. That will again emit the signal that the grab changed. Subscene delivery agent is going to set the exclusive grabber context to itself. The next thing is that the 3D viewport will see that some grabs have happened in that subscene, and it also needs to remember how to do the transform from scene to subscene coordinates. It creates this viewport transform helper, which is an implementation of a pure virtual class in QtQuick that lives in QtQuick 3D and embodies the transformation from the viewport to the 2D subscene. So it creates this class and it calls setScene transform on the subscene. So then let's say that the next thing that happens is that the mouse moves with the button still being pressed. So this is a drag now. And then it wants to construct a mouse event, and it calls event on its top level window. And the QQuick window is going to get the event point data because now it wants to find out about existing grabbers. So it finds that there is an exclusive grabber, and therefore it gets the exclusive grabber context, sees that the exclusive grabber is a subscene and it has its own delivery agent. So now, rather than going through all of the stuff that we did before, we're skipping picking, we're skipping event delivery through the main 2D scene, and we're going directly to the subscene first, because that's the context in which the exclusive grabber occurred. So we call event on the subscene delivery agent, which will deliver the pointer event, and then it's going to use that this viewport transform helper that was created here and set. Now it's going to use that and call map on it to directly convert the scene position from the root 2D scene into the subscene. And then we start looking again at the grabbers. The exclusive grabber has to go first, so the event is going to be delivered to this item which had the exclusive grab. And then it goes to the passive grabbers, and it calls handle pointer event on this drag handler, which was the passive grabber in the subscene. So now we're done with the subscene, and we go back to delivering in the main scene. The delivery agent that's constructed along with every window is now going to deliver this pointer event, and it sees that there's a passive grabber, which is the tap handler on the cube, and it calls handle pointer event on that. And we're done. Okay, so here's a little bit more real-world example, and I've demoed this before. This was from a few months ago. So I have a View 3D, and at that point I didn't know how to use Blender yet, so I actually made this casing of this device in OpenSCAD, and you can see that you can rotate it around in the 3D world. So OpenSCAD generated me an STL. I used Balsam to export that to a mesh file. It has no texture. It cannot have a texture, but it can have a color. So I have a View 3D with a scene environment, which is a skybox, and that's just something I downloaded from the net. It's an image of somebody's kitchen. And then there's a spotlight and a camera, and here's my case mesh, and then I separated out the buttons. I made those separate models in OpenSCAD, and so I can actually press these buttons in 3D because each of the buttons has a tap handler on there, and then I change the Z position when I press it. If I press this one, I get confetti. It's this the 3D particle engine, which is something new in 6.1, I think. There's a particle system 3D. And there are some bugs when we're using Qt Quick controls together with 3D, so I'm actually not able to interact with much of this Qt Quick content inside the 2D scene, at least not inside the presentation, but if I run this standalone, then it works. Okay, so this is the one that I was working on last weekend. I thought, let's try to get even more realistic, and I found this on a website. Somebody has created this model of an old mixer. So let's turn it on, and well, you can see I animated the VU meters. It's pretending like there's some music playing. That's just an animation, and I put lights inside the VU meters because that's what they usually do. So if you turn the ambient lighting way down, you can see that there's light coming out of there, but the meters actually are letting a lot of light out around the edges. They're not really as opaque inside as they would be in the real world, so it's lighting up a lot of other stuff here too. There's light bulbs inside here, and it's lighting up the sides of these sliders and so forth. And then this slider I wired up to control the directional light here. That one. See, the brightness is obj phono 1 slider value, and sometimes I'm able to use the wheel handler on this knob here to rotate it, and all of these sliders are interactive, but they don't really do anything else. So so this was a static model that somebody had created, tried to make a realistic rendering of a real world object, and I took that and made it interactive, and we'll talk about how in a minute. So there's this Mixeta QML which was generated by Balsam, and I just wired up a bunch of stuff in my UI here to make it a bit alive. So here's the workflow that I used for that model. I found something interesting on Sketchfab, downloaded it as a GLTF. I imported it into Blender because I found that I needed to actually split the meshes of all of those knobs into separate objects so that I would be able to rotate them in QML. In Blender, I re-exported it to GLTF. Then I used Balsam to import it, and that wrote my QML for me. And then I just wrote the rest of the scene, the QML View 3D. And first I just made sure that the Balsam scene actually worked. But anyway, the Blender work, let me just give you a couple of tips here. It turned out that the way that this guy modeled this mixer, he put everything together by material. Well, the knobs are a different material, some phenolic or something like that, so the knobs are a separate node. And then this aniso is the anodized caps on the knobs. But I just wanted to work with the knobs themselves. So the first thing I have to do is, you see these eyeball icons, I had to just turn off the things that I don't want to see, because when you try to pick vertices, all that other stuff will get in the way. And so you see that it looks like the eye is shut. That means you can't see it anymore. So you click on those, and then you do lasso selection, and you will select some vertices, but only the vertices that you can actually see from that particular angle. And so then the next thing I do is select linked to find all the vertices that are connected to the edges that those selected vertices are connected to. And then I look at the scene from a different angle, and I find out there's still some more vertices that aren't selected. So then I hold down the shift key and lasso some more, and I select some more vertices, and then I select linked again, and then I look at it from a different angle, and there's even more vertices that aren't selected. So I had to do that several times until I finally got all the vertices of the knob selected and nothing else. And then finally I'm able to hit the P key and create it as a separate object. So that was in edit mode, where I was editing vertices. And then over here I'm in object mode. So here I've got the entire object selected, and now I can worry about moving its origin. So object set origin, and then you have choices. You can set it to the center of mass, or to the, if you've already moved the 3D cursor, you can just move the origin there. So it seemed like the center of mass thing works decently, although I'm suspicious because there's a cutout here for a set screw, so that's going to alter the mass, and also there's a cutout for the little indicator on the knob. But it seemed like it was pretty much at the center after I had done that. And then I also have to move the 3D cursor to the center, and then finally I'm able to, maybe it's better to show it live. So I get on this blue thing and I can rotate this knob around its axis now. After I exported the GLTF scene from Blender and imported it with Balsam, it wrote this QML for me. It's possible to actually remove these outer nodes and kind of collapse it all so that you just have the root node, which is what I did. And you'll see that there's a bunch of textures here for the materials. It writes all that for you, exports the PNG files and the mesh files, and we've just got a bunch of different materials, and then they end up getting reused when we get down into the actual knobs. You know, here's that micro base knob, and it's just reusing the existing material that was declared above inside one of the other knobs, and the same thing for all these anodized caps on the knobs. And then the view meters I also had to separate out into separate objects so that they're able to be rotated so that I can animate those. So next I take this output from Balsam and try to make it interactive. So I simplified the QML, as I mentioned. These quaternions are hard to work with in QML because at least I don't know how to change the numbers to make the knob rotate in place. And so I used qquaternion to Euler angles. That's a C++ function to do the conversion to Euler angles. But there isn't a way to do this in QML yet, as far as I can tell. So I wrote a little widget application just for that purpose. It works with text, so I can actually just, in Qt Creator, I can select a quaternion's values and middle mouse paste it into this tool, and then it will parse it and convert it to a quaternion, and then it converts it to Euler angles and puts the text of that, and then I can select that text and paste it back into Creator. I have to declare pickable on each of those knobs that I want to be able to rotate, because picking in the view 3D will skip anything that's not set pickable. And then it turned out that I couldn't pick those knobs anyway. That's some sort of a bug, but at least it worked with the slider handles. I was able to put handlers on each of those slider knobs, and then I'm able to drag them. So if you're using drag handler, you'll be interested in this persistent translation property, which is a new thing in 6.2, because drag handler translation is an instantaneous amount of translation, which just shows how far the drag handler has been dragged since the time when you pressed. But what we actually want for a mixer knob is to keep track of how far it's been dragged for all time. I now think that it was a mistake that I didn't make all of those properties that way from the beginning in pointer handlers, but that's my mistake, and we can't just make sudden behavior changes now, and so therefore we have to start adding more. We have this new pattern that the persistent properties are going to be called that. So persistent translation is the amount of translation that's happened since the drag handler existed. Wheel handler rotation, on the other hand, already is persistent, so I think maybe we should rename that now to persistent rotation. But anyway, it's the amount that the wheel on the mouse has been rotated since you started your application in degrees. So that's useful for binding to knobs as well. Of course, the problem is if you keep rotating your mouse wheel past the stop, past the point where you can't rotate your 3D knob anymore, then you get too far ahead of it, and then you have to rotate back a long way on your mouse wheel. So we need to deal with that somehow. The tap handler pressed property is useful, of course. The scale and the translation on the pinch handler are useful, but so far we haven't added the persistent translation properties. I'm proposing to add to handler point the model position and the world position as QVector 3D. You can actually get the 3D positions in QML when you're using any of these handlers. Here's a diff before I actually simplified the root nodes, so I still have all this nesting going on. I just started adding properties. I want to keep track of how far each of these knobs have rotated, and then I started converting the rotations, like I mentioned, with that widget application that I wrote, from quaternions to Euler rotations. Okay, so I have this property to keep track of, for example, how far this microbase knob has been rotated, and so I have to actually make the rotation happen here. And then there's also a handler down in here somewhere where I attempted to set it, and then I had the problem that it's not pickable. So here's a slider. This drag handler actually does work. Then I just use its persistent translation up here to directly set the Y value. And the problem with this is that the drag handler drags in pixels, but in 3D we're in completely different units. And so I just did a kind of ballpark conversion here, divide by 2000, and that's really not very accurate at all. I could have divided it a bit more. But we probably need to come up with a better solution for that as well, to convert deltas in pixels to deltas in your 3D space so that you can actually drag it. Or else maybe we need to make the drag handler smart enough to do this on its own. But the trouble is drag handler lives in Qt Quick, not in 3D. According to the separation of concerns principle, that's not its concern, which is why I was using bindings here. I also have I used a boundary rule on the Y property of the model to make sure that you don't drag it outside things here. I used a boundary rule on the Y property of the model to make sure that you don't drag it outside of its groove, and that turned out to work pretty well. Boundary rule was added in Qt Quick mostly to make wheel handler behave, and it's a property interceptor. It's kind of like behavior, so you can apply it to a property and it will make sure that that property never goes out of a certain range. So that turned out to be just as useful in 3D as it is there. Okay, here's a really simple manual test that I'm proposing to add, which shows how to use these new handler point properties. So I have a sphere, and then I have another little sphere, which if I hover, you'll see that that sphere moves around to the hover point. So there's a hover handler with IDS HH, the sphere's hover handler. And I'm proposing that its handler point should provide this world position, which is in 3D now. And so I can directly bind the position of another sphere to that world position. And therefore, when I hover on the big sphere, then the little sphere moves around to the same position, just with a plain binding. And then I did the same thing with this cube over here. And I'm also using bindings to update some text down here, just to show you where you are in both the model and world coordinates. And yeah, there's also a tap handler. I can tap the sphere. Same thing there. And I can use pinch handler, but I'll have to show you that on a touchscreen. Now I'm showing you the same thing on a touchscreen, and now I'm able to either use two fingers to move two handlers at the same time, or I can use the pinch handler, and I can rotate this cube by dragging my pinch around, and I can resize it by scaling the pinch. Okay, one more little demo. This is how you can do ray picking in QML. I mentioned earlier that the normal way that View 3D does ray picking is it sends a virtual ray straight down into the scene from the mouse cursor position, and it finds out what you're hitting. But let's say you're in VR and you have some other kind of controller which can point in arbitrary directions, like this. So I have this little spaceship here, which is pretending to fire a laser, and sometimes it's able to hit an object. So how does this work? The spaceship has a position and it has a forward vector, which tells you the direction that it's pointed. So in QML, you can call this view as the View 3D, declared at the top. And you can call this ray pick function, giving the position and a direction vector, and it will tell you the first object that you hit. And so we find that, and we measure the distance to that object, and then we set the length of the ray, which is actually just a cylinder, to that distance. And then we have a particle system that's emitting particles at that position as well. So that's why you see that. We have this repeater 3D, which is a way of creating actual instances of these donuts. So we're actually making multiple copies of the donut model. The other way to create multiple instances is with instancing, but then those are not actual copies of the model object. It's just a rendering trick. So in this case, these donuts are real, so to speak. They're actual copies of this model being repeated by this repeater 3D, which is kind of like the repeater in Qt Quick. It creates actual instances. So the other interactive aspects are we have a wheel handler on the scene, so we can zoom in and out, and there's a point handler which reacts to the middle button, so I can rotate the scene. So if you're not using the WASD controller, that's another way that you can get the same kind of behavior. But that's being used to rotate the spaceship in this case instead of the scene. So the WASD controller, you can set the controlled object to either the camera or to something else, and then you can use the keyboard, WASD keys to move it around, and you can also use the mouse to change the angle. So what do we have left to work on? Well, we're trying to still get consensus on the team whether this idea of reusing the existing 2D handlers in 3D is actually a good idea. The upside, of course, is that there will only be one set of handlers to maintain, and they are exactly the same, and therefore the API should be the same. On the other hand, as soon as I implemented this feature, it seemed to break Designer a little bit. Navigation inside this QML puppet that it uses to visualize the scene. It also seems like Drag Handler is never going to be able to directly drag 3D models because it lives in Qt Quick. It doesn't know about that. And so we're going to have to come up with a way to convert the 2D mouse deltas to 3D deltas. Hovering doesn't always behave consistently when you've got complicated scenarios with 3D embedded inside 2D, inside 3D, and so forth. I think there's this bug that I couldn't pick the knobs in my scene, and I don't really understand why. I'm not sure if that's a bug in picking or if it's just something wrong with my model. The WASD controller also seems to steal mouse events that you might want to deliver to something interactive. And controls are stealing events. As soon as you put controls in the scene, then they don't work the way they should. So suggestions for you guys, for the community. This is really a lot of fun. I think that you should already enjoy playing with it, even though the interactive stuff is incomplete. I mean, you can feel free to pick those two patches and you can play with it and try to imagine that you're living in the future. Try to imagine what you can use this for outside of games. What kind of KDE applications, for example, could really make good use of 3D? When I was writing this simple model viewer for that Apollo command module, I was having a hard time finding toolbar icons for it. So that was something that I noticed. I think if there are designers in the community that are interested in creating icons, it would be nice to have a standard set of icons for 3D applications for stuff like turning the axes and the grid on and off, rotating to different standard positions in 3D and stuff like that. Just all of the toolbar icons that everybody's going to want. Yeah, some of this stuff existed from before. We had a hackathon a couple of months ago in which we created this fancy spaceship with a Wayland compositor on different screens inside. Code has not been open sourced yet. At least there's a demo video of that. The digital assistant, on the other hand, is my creation, and that is open source. And there's a demo video of that separately, going into more details. And well, that's the end of the presentation. Thanks for watching. I hope you had fun. I hope it inspires you.
Thanks. Oops. Sorry. In a minute. Thanks, Shawn. That was very impressive. The chat was already talking about bringing back skeuomorphic user interfaces and keywin special effects, but let's not go there. Yeah. We have two questions. Any chance of a proper vector API in QML? Things like being able to do Qt.vector3D 1.0, 0.0, 0.0 multiplied per 10 for scaling?
That's a good question. Okay, so you're saying that I haven't actually, have I tried that? I think maybe I tried that once, yeah. So multiplying by a scalar is actually missing, is that what you mean? Or
that's what they are asking, it seems.
Yeah, I mean, that's more of a question for the QML engine guys, but yeah, Wolf and so forth.
Another question is, any consideration for VR support in Qt Quick 3D?
Yeah, and that's something that Andy Nichols is really into. So I think he's probably going to come up with something. But that last example that I showed with array picking would give you an idea how you could do that. If assuming that the controller gives you a position and a direction, then you should be able to do the picking the same way.
Okay, we don't have any other question so far, and we are strict with the times. So I guess we can thanks all, Shawn, for the presentation. So big round of virtual applause for this. And I guess your people can contact you on the all the places you just showed in the slide. So thank you again. And we will continue in 2 minutes.
Okay.
Hello, Thomas. Welcome. I can see the camera.
Hello. You can hear me?
Yes, I can hear you. So the stream can hear you as well. We have still 1 minute to go, so everything seems to be fine.
I will share a screen in the middle of the presentation, but otherwise I will use the slides as they are here, just by clicking through them.
Yes, you should be. You are a presenter now, so you can control them.
Yeah, I see the controls.
Perfect. Okay, so just another minute. This is the last talk, Qt Design Studio, an introduction, as you can see from the slide, from Thomas Hartmann. This concludes this track, small Qt track during the Academy, and also concludes the presentation in this room, but don't run away. We have still another talk and the final part of the Academy in the other room, in room number 1, after this talk. So stay with us. And I guess we can probably start. So it's all yours.
Hello, welcome to Qt Design Studio, an introduction. So I'm Thomas Hartmann. I can briefly talk about myself. So I'm a senior R&D manager for the Qt company, and I lead the Berlin team that works on Qt Design Studio. I joined actually Trolltech in 2006, worked on various topics. One of my first assignments was Windows C, worked a bit on Qt Creator, did consultancy. But in the last years, I've mostly worked on what's Qt Quick Designer and now Qt Design Studio. So, I skipped one slide, sorry. So first, I want to give you a brief overview. So I want to start with an introduction about Qt Design Studio. I want to explain a bit what Qt Design Studio is from a high level. And then I will give a demo and showing you how Qt Design Studio can be used in practice. And then, because that's, I think, really interesting for this audience, I also want to talk a bit what's behind the scenes of Qt Design Studio, especially how we use Qt, what is the source code, and so on, and also what technologies we use. And in the end, there will be a bit of time for questions and answers. So, yes, what is Qt Design Studio? Yeah, it's Qt's dedicated design tool, and it can be used to create UIs. It can also be used to define the UX, the behavior of these UIs. Yes, you can work with 2D and 3D, and you can use QML for that. So QML is the underlying technology. So Qt Design Studio always works on QML files, and QML is basically the representation for the UI. So there's no technology switch when you hand that over to an application developer, C++ developer. So everything is always QML based. A bit under the hood is Qt Design Studio is based on Qt Creator. It's an adjusted and optimized version just for QML editing and for Quick development. So we turn off the C++ parts, basically rebranded a bit. I will talk about that later. And the last version we released is, or was, Qt Design Studio 2.1. And we release always a commercial licensed version and the free community version. I will briefly talk about the differences. Okay, so what can I actually do with Qt Design Studio? Yes, you can develop UI designs with a WYSIWYG editor. That is what I will mostly show in the demo, and that is what a lot of people will spend their time with. But you can also create animations based on the timeline. I will briefly show that also as part of the demo. You can define UI logic with states and binding. I will also cover that. You can create your custom controls. I will create a simple button in the demo later. You can import designs and assets, and we'll not cover that today. So for 2D, that's Photoshop, Sketch, and Figma. And that is basically the main feature that's just in the commercial version. And for 3D, you can also import for Maya, Blenders, and others for 3D assets. Yes, and with this, you basically can turn your designs into working QML. You can create prototypes or fully functional applications even. What you cannot do is basically the C++ parts. And finally, you can deploy and run and profile on target hardware. I will not cover that today, but with Qt Design Studio, you can actually deploy to Linux hardware and even profile. Okay, the latest version is Qt Design Studio 2.1. I already mentioned that. Yeah, we have the bridges to import designs. Then we have the visual 2D editor. We also have an integrated text editor. I will show that. There's a visual 3D editor for Qt Quick 3D. There's a flow editor. I will not cover that today. There's a state transition editor. I will briefly show that. Yeah, we support the Qt Quick layouts. I also will show that a bit in the demo. Yeah, all the ready-made and reusable UI components you're used to from Qt Quick come with Qt Design Studio and even a few more. There are timeline-based animations, a couple of customized visual effects, and there's also the live preview, which is also a very interesting feature I will briefly show. So you can basically live update your application while working on it. Okay, yes. The first release was actually Qt Design Studio 0.1 was in December 2018. And since then, we regularly released new versions. Figma support was one of the items we added in the last two releases. We did lots of UX improvements, improved the usability in general. And for the upcoming release, we work on full Qt 6 support and also on, again, many improvements to the UX and especially the property editor. I will briefly talk about that later. Okay. And with that, we come to the demo. So I will now share my screen. So what you can see here is Qt Design Studio. This is the welcome page. This was the first thing that you will see. And on the welcome page, there are a few demos that come with Qt Design Studio. I will show a few of them later. But for now, let's start with a new project from scratch. And I choose a resolution here for this, not too fancy. It's just a nice wizard that sets up a project for you. And then Qt Design Studio starts, and it has created one screen for you with a text in the center. I delete that. We don't need that. Yeah, and there's lots of functionality you can do. For example, you can easily change the background color here. We have, like in every design tool, we have a navigator. For now, we just have one single root element here. Yeah, I briefly mentioned the text editor, but I will show that later. So I just drag in a rectangle here, and then we can anchor it. So it supports the anchors that you have in Qt Quick. We can change the color. We can also change the radius. Yeah, and this is basically what we typically expect a technical artist or designer to do, to basically use the visual tool to create some visual design. It could be imported from Figma or Photoshop, but you can also create it from scratch. And even imported designs, of course, you can tweak here. And now I just continue dragging in a label. You see all the text properties here, and I change the color, adjust the font size a bit. So no surprises here. That's just how you use it. I will briefly talk about the property editor later, how we implemented that one. That's implemented in Qt Quick using Qt Quick Controls 2 and our own custom style. And I now created a layout around the 2 text items I created, and I just rename them. So this is basically typical day-to-day work. And the goal here is that I create a very simple UI, show a couple of features. So the 90%, for example, I will skip that here, would typically be binding to something from the backend. Right now, we just keep it hard-coded. And yes, so without touching any QML code, I can create this, and I use copy and paste in a few cases. And now I'm basically done with the basics here. I move that around a bit. You can see I have snapping here, so things snap to each other. There's also another nice feature. We have alignment features similar to what you see in Illustrator. So now I distributed them actually, but that's not exactly what I want because I want 2 columns. So let's use the distribution feature again here. So I distribute them evenly, so I don't have to do that by hand or rely to just my eyes. And I can also have alignment features. That's pretty much what you know from Illustrator. That's really nice if you want to do absolute designs. Of course, you have all the layouts and anchors, but sometimes maybe you just want to have one single resolutions, and then absolute layouts are easier. Okay, I put everything into a group, which is a custom item that only comes with Qt Design Studio. It's basically just an item that automatically takes the size of its children, so nothing special here. And I distribute here again. And I think, yeah, now I kind of would be done with this as a UI. Anchor it a bit here. So by centering it. And yeah. This was basically typical day-to-day work with what you do in Design Studio. But now I want to do something a tiny bit more fancy. I want to create a custom button. So I create from the wizard a new component, and I choose button. And by default, it has two states for normal and down. And I can now edit them in the WYSIWYG editor, in the editor mode, and adjust my button a bit. Yeah. So select the background, give it some radius here, so it's now a bit round. And it's also a nice place to show the live preview. So now I run the live preview of that button, and that's basically an interactive preview of the button. It's basically like running the button, but there's a tiny difference. That is, if I do now a change in the editor, in Design Studio, it's immediately propagated into the application. So you see that the running button basically is also updated. That's really nice in this case. So I now change also the label color. And I still have my working button, and I don't have to constantly restart. It's useful if you do a component like a button or anything that's complicated. Also, if they're running animations, that's super helpful because you can see constantly the animation running. Basically, just properties, so we can go back. Oh wait, first I want to show you transitions actually. So this is a transition editor, and that adds automatically transitions to our states. And I can now change the duration a bit to make them more visible. And now instead of the button like it was before, it's animated. There's one trick. Because there's no animation, I have to make the normal state the default state. But now we see that there's an animation when I press the button. And it's a few clicks, as you can see, and you can easily tweak those, even using easing curves and so on. So, but now let's really go back. The form I created, and on top of this form, I will now want to use now my custom button, and was added to the item library, even has a preview here, and I can drag it in. And I drag in 2 copies of my button, my custom button. Give it a name. And position them. Yeah, this is really powerful. You can create your custom components in Design Studio, nest them. Actually, no, I lock the layer here. This is a feature we recently added. So I cannot accidentally now change the layer anymore. And then I use anchors to the margin to position my buttons. And now they have the same distance to each side's 32 pixels in both cases. Yeah, locking is super useful, especially in this case, because I might otherwise accidentally move a label. And now I can show you the QML code. So this was the code that was generated. And yeah, you can, even if you use basically the mode, the text mode inside Design Studio, it's really hooked up with the property editor. So we can work in parallel. You can do a change here. Now I broke it. There's a syntax error that basically will block the UI until I fix it again. But see, now it works again. And I can use the property editor in parallel. And I see the changes. And one thing is the doc widget framework. I will also talk a bit about that later, because it's a special doc widget framework and it's very flexible, and you can also like put it next to each other, and I will keep it like that for now. That's also very useful if you want to tweak the QML text a lot, if you want to do some optimizations, or maybe you are a developer and care about details. You can always see the text and the visual editor in parallel. Now I created 2 states and give them name. So also here, no surprises. Now I start to make the buttons checkable. And in one state, I make my whole UI invisible. So we have the operate state and the maintain state. And the maintain state, the labels I added are invisible. Okay. This is checked here. Then there's also exclusive, which is super useful, because exclusive will basically automatically say that only one of these buttons can be checked at the time. Before I continue, I want to give the buttons proper names, because I want to refer to them in when conditions, and then it's important that they have a good name. And here I can now refer to the check boxes, to the checkable buttons, and I can basically define the when conditions of each state without having to write code, just by using the combo boxes, which is very convenient for people who are not, let's say, not very professional developers, who are not very used to writing code. So now I can also run the live preview again. And yes, you see that we have basically a very, very, very simple running application without writing any code. And of course, you can continue like that. But I also want to show you a few more advanced features. That's why I, for example, will now open the e-bike demo that comes with Qt Design Studio. And the e-bike demo heavily uses the timeline. And I want to show how the timeline is used here. So we have many states in the e-bike demo. And there are many transitions between those states. And we didn't use transitions because they don't always allow to fine-tune the animations very well. In this case, we use the timeline and basically defined each transitions very explicit using keyframes. But that gives the designer a lot of control. The transitions don't have to be symmetric. You can add keyframes in the middle. And you can really make sure that the transition looks exactly like you want to at every every pixel, basically at every point of the animation. And for the timeline, we also have a curve editor. It's a very powerful curve editor. And here you see that there are also easing curves between the keyframes. That's something that's more common in 3D tools, but that's a very powerful view on this. And to give you an idea, let's just run this. So yes. So basically, when I interact here, I switch the states, and the timeline is then used to animate between those states. These are exactly the same animation that you saw when I dragged the timeline handle before. Okay, now I will show you the welcome page of Qt Design Studio. So the welcome page of Qt Design Studio is also developed in Qt Design Studio. And that's a relatively interesting example because it has a C++ backend, and we mocked that up with QML. But first, I want to show this. This is basically the screen of the welcome page, the recent projects, examples, and so on. And yeah, it's done in Design Studio, nothing too fancy here. And we could now adjust it, change it, whatever we want to do. And it actually was developed by our designer, and it's also maintained by our designer. You can also run it, and something shows up here in the recent projects because we have this mock backend. And that's a very powerful technique to basically mock up the C++ backend with simple QML that can be understood even from the designer, maybe even tweaked by the designer. In this case, it's very, very simple. You look at the text there, it's just a list model, basically. And there are a few more of these. But that's a very powerful technique because now we have a project that runs fully in Design Studio, really can be owned basically by the designer and can be just integrated. And here is the trick. We have a couple of import paths that add the mock data as QML plugins. And those mock plugins, of course, are not part of the C++ part. And on the C++ side, it's just loaded by the Qt Creator plugin. It makes it possible to develop it in Design Studio in parallel to having it in the C++ application. Now I want to show you the digital cluster. That's a downloadable demo. I downloaded it before. So let's just open this. And that's a demo that shows a lot of the 3D capabilities. So Qt Quick 3D. And I'll start with the main screen here. Okay, you can see it. So that's a cluster, and that uses quite a lot of Qt Quick 3D. So to give you an impression, I just run it. It had a light and dark theme. It was actually developed by a technical artist purely in Design Studio. It has no C++ backend, but you can do a lot of stuff just using QML. So you can turn on the lights, open the doors, rotate it. You can see that you can even have 3D and 2D and then 2D and 3D again. This interior view, here's a battery view with a nice animation. And there's the ADES view. And that was all developed in Qt Design Studio. And I want to show you a few of the files. So that's the ADES view. And the ADES view doesn't have a backend. And it's really just basically mocked. And the timeline was used for that. But that's actually powerful technique while you're in the prototype stage, because you can always mock it and you don't have to worry about the implementation at this state, but you can already define how it will look. And yeah, now we have another screen that has different states. You saw on the UI, and those states were all defined by the technical artist. And yeah, that's a battery animation you saw earlier. And you can create such a demo with either writing no code or just very limited amount of code yourself. I mean, of course, you can always go to the QML code. That's your choice, right? And yeah, for example, here's a component, right? One thing that makes QML so powerful is that you can have all these different reusable components. And there's some structure that the technical artist was setting in place. And you can always look at the text editor. Yeah, with that, I want to stop with the demo and get back. So, okay. Yeah, now I want to talk a bit what's behind the scenes of Qt Design Studio. So hopefully you now have an impression what it can do and what it's meant for. But I also want to give you an impression how we develop it, how we use Qt. Because we are basically, yeah, especially on the front end side, we're a heavy user of the Qt and Qt Quick technologies. So Qt Design Studio is a pretty typical Qt Quick and Qt cross-platform desktop application. So it's a pure desktop application. We are currently in the process of porting it to Qt. We have a working version and just ironing out the bugs. Qt Design Studio is, that's no surprise, available for Windows, macOS, and Linux. So, and I briefly want to talk about our main challenges, in a sense, when it comes to the Qt stack, and that's with graphics driver on Windows. We sometimes have problems with those because, yes, we use Qt Quick and even Qt Quick 3D, and there can be issues because of graphics drivers, and those can be quite nasty because it's not on our control, and we might not even have a machine to reproduce those. Another thing that's a bit challenging is sometimes that Linux is a very heterogeneous environment. So that's why we officially only support Ubuntu 20.04, the latest LTS version. I mean, we tested on more Linux machines, but we don't commit to more installations. It's just, yeah, especially the different window managers are sometimes a challenge, but also the drivers and so on. But all in all, it works quite well on Linux, and actually we have surprisingly many Linux users, even in a commercial environment. Especially people who like to, or who develop in embedded Linux or for embedded Linux, they like to have all their tools on Linux and don't want to switch to Windows or Mac OS, just for Design Studio. Okay, so what is Qt Design Studio? Technically, it's a customized version of Qt Creator. It's no fork, so it's usually always based on the latest version of Qt Creator. That's how we always did it until now. We don't plan to change that. Yeah, we brand it a bit, which means we rename the executable and exchange the icons and so on. But that's basically a few switches on the build system. It's also upstreamed. You can even see how we do that. So there's really no black magic on that. The packaging is done a bit different because, for example, we ship our own version. So that makes our a lot easier because we basically know that Qt Design Studio is always based on the same version of Qt, the one we ship it with currently Qt 15.3, and because that was one of the biggest problems with the Qt Quick Design and Qt Creator, that we don't know which exact Qt version it's used with, and that creates a basically combinatorial explosion of potential issues, and it's basically impossible for us to provide a constant quality. And this becomes a lot easier. In this case, we test our packages, and if they work, they work. And we can really provide a relatively high quality. Another thing that's special about Qt Design Studio is that it comes with a couple of custom components that come from a special repository. These are QML components, actually quite a lot of them by now, for the flow editor and things like arcs that are based on the QML shapes, and a few MCU specific things, and quite a lot of components in the end that basically just ship with Qt Quick Designer. But those components, they are also open source, and they are living in that repository, and eventually we also make a plan to make them part of Qt once. But we don't want to make that too early because we don't want to commit basically to the final API and the final implementation too early. Some parts are closed source, so okay, that's a bit unfortunate, but that's how it is. So actually, there's a plugin that we add to Qt Creator that contains the closed source parts. So that's just a plugin that's just part of QDS. It's called Qt Quick Designer, and yeah, the biggest part of this the biggest closed source parts are the Qt bridges, the importer. There are also a few other things, but they are often just closed source because we didn't meet the feature freeze for Qt Creator, for example, and then we move them over in the next release. this was the case for the timeline, for example, that we eventually moved over to Qt Creator, and we just recently moved over the event list, which is another feature I didn't show here, that is basically part of Qt Design Studio that was closed source that we then eventually moved over to Qt Creator. Yeah, one thing that I really like is the Qt Advanced Docking System. I didn't show it in depth in the demo, but it's not a normal Qt docking system, but it's a different implementation. It's based on the Qt docking system, but it adds a lot of features. It was contributed to Qt and Qt Creator by Uwe Kindler, who's the original author. It's licensed under LGPL v2. And yeah, you can get it from our marketplace and also from GitHub. That's basically original, that's developed by Uwe Kindler. We also maintain currently a fork in that's part of Qt Creator. And yes, why do we use it? So because it has a couple of really nice advantages and features. I think what was the most important feature was that it has no central widget. So it's more flexible. So it has no concept of a central widget. And you already saw that when I split it, the form editor and text editor view, that this really is a very nice and powerful features in the context of Qt Design Studio, because yeah, it makes the workspace a lot more flexible. Another feature I really like is the clear visualization of the drop targets. You can see that here in the screenshot. It's very similar to what other tools like Visual Studio do. People understand it. It's relatively intuitive. There are more features, especially when it comes to stacking and docking. Also comes with perspectives, so you can switch layouts easily and so on. Perspectives can be built out, of course, also on top of the Qt-based one, but you get it basically for free. Yeah, and that's what we use in Qt Design Studio, and I think it's really a great addition, a nice contribution, and feel free to test it out if you need a powerful doc widget framework. Yes, so we are also a heavy user of Qt Quick for desktop applications. And that's why I also want to talk a bit about how we use Qt Quick, what is our experience, what we like, what we don't like, and so on. So in short, we use it for the welcome screen and splash screen. Those are relatively simple parts. The welcome screen are already covered. The implementation is kind of really simple. I think it's a really nice and great test case and also use case for Qt Quick in general. It's nothing complicated. You can really hand it over to a technical artist or designer. He can basically own the whole welcome page with a little bit of help from a developer here and there. And that's really nice workflow, and they can build it in the way they want it. And we just integrate it into the C++ application. The property editor is a bit more complicated. I will talk about that in a few seconds. And then we also have the item library, which is also a bit more complicated. So both of them are basically maintained by developers, not by designer anymore, because yeah, they contain quite a lot of code and they are mostly fully dynamic. And then there's also the states editor, who is similar. But even there, the designer can help, because we can give him stripped down projects that are pure QML. He can basically define the look, adjust it. You can also give access to him, and he can tweak around with the designs directly. And we did that actually. So yeah, the welcome and splash screen, there's really nothing I didn't mention already, kind of. It's really pure QML. It has a very simple C++ backend that's very easily mocked. And it basically works as a standalone application in Qt Design Studio. It also tests that test case for our workflow. Yes, the property editor is actually quite a beast, so it's really complicated. The property editor uses customized Qt Quick controls too. And yeah, we are quite happy with the result. So there are a couple of features that you don't have typically for example, you don't have with widgets and so on. So for example, you can drag on the spin boxes. Also, we don't show most of the controls by default. So most of the sub controls you only get when you hover on the controls. That reduces a lot of clutter, and it's actually quite typical for modern applications. And all of this would be possible, but very hard to implement with widgets. And we did that. We decided not to do this. So we used Qt Quick Controls 2 and Qt Quick. And we're really happy with the results. Another thing that's worth mentioning is that the studio controls are fully resizable. So every number basically comes from a small theme, and all the magic numbers are usually based on or use one scale factor, and by tweaking that scale factor, they are fully resizable. We don't expose that to the end user at this point in time, but it makes our life a lot easier. Yeah, because basically all the numbers, all these magical numbers, they can be controlled by the designer, and therefore he can really own this. Yeah, we also hooked this up to the theming theme of Qt Creator. So the colors actually come from the theming scheme or theme of Qt Creator. So that way it works in all themes, which is also nice. And yeah, the studio controls are part of Qt Creator, so they have the usual license, and you can look at them. I think it might be really interesting if you build something similar to have a look at them and maybe even use them. Okay. Yeah, let's briefly talk about the advantages of using Qt Quick in the front end. So it's really easy to customize the look and feel. I think it's really a lot easier than doing that with widgets, and I also have some experience on that side. And it's also a lot easier to implement modern and advanced UX. Yeah, you can use Qt Design Studio for the front end. That's also, of course, nice, especially from our perspective. The designer can take full responsibility of simpler parts like the welcome page, or at least help out on more complicated parts with the property editor. On the property editor, there are always things the developer has to help out, but he can always help with the layouts, basically maintain the colors and magic numbers and so on. One thing that really helps a lot is hot reloading. So all our views support hot reloading. So by pressing a hotkey, it will reload the QML code, and that allows very, very fast feedback cycles, and that's just great. And you get used to that very fast. So you press one button, and then you can test a different behavior or different size, or one bug is simply fixed, no recompile, nothing. Another very powerful feature is that the property editor, for example, can be extended with external QML files that come or are shipped with QML modules. So yeah, it makes the property editor very extendable from the outside without having to write C++ plugins or anything like that. You can just basically write a QML file that extends the property editor for a specific file type. Okay, what are the challenges? Yeah, the bindings between C++ and QML, they require a bit of overhead and boilerplate code. I don't think that's a showstopper or anything, but yeah, it's a bit of extra work. What is more serious is that the developers who do this work, they have to be experienced in both C++ and QML and Qt Quick. This can be a bit of a bottleneck. And in some cases, Qt Quick is not as mature as QWidgets for desktop development, especially if you think of tree views and so on. That's still not the case. I mean, we're really heavily working on that, but yeah, there's still things you might have to work around or experiment a bit. And yeah, there's also the dependency on 3D acceleration, which sometimes can be a problem because of drivers, and generally because of basically having two languages, there can be high complexity, and you have to be aware of that and be careful. So basically, all the logic we put purely in C++. So roughly, our rule could be something like no loops in QML. So if anything is slightly more complicated, it becomes C++, and really just the simple parts are QML and JavaScript. Another thing we added is Google Crashpad. Yeah, that collects stack traces. It's no technology bus, it's part of Chromium, but I think it's worth mentioning here. It's opt-in because it can contain confidential data. We use Sentry as a backend service, and you can also look how it works in our source code, and part of Qt Creator. Might be worth looking into it if you want to collect crash dumps on desktop platforms. And another thing we added recently was telemetry that's based on k-user feedback. And it's also opt-in, of course, and we collect lots of data, usage behavior, usage pattern, but we also added a dialog that explicitly asks users to rate features and so on. That's pretty typical for modern applications. And k-user feedbacks make it really simple to implement. There's already a Qt Creator plugin that helps us with that, and we just sit on top of this. Yeah. If I want to try out Qt Design Studio, you have two options. You can download it using the Qt online installer, or the latest, or you can always get the releases also from our download page. So that's a standalone installer but the standalone installer only works for the free community version. While if you have a license and you have a commercial license, then you have to use the Qt Online installer. But yeah, please give it a chance, try out. With that, I say thank you. I hope you learned a bit and got an overview about what Qt Design Studio is, what it can be used for, and also like how we use Qt, and maybe something that you can use for your own Qt application in the future. Thank you, and have a nice evening.
Thank you, Thomas. So I don't see any question right now. There is some feedback chit chat on the chat. There are people who are wondering how to find some customers who can pay them to use this tool. So that's kind of probably.
But you can always try the free version, so we don't need to. Right, the basic is you only absolutely have to pay if you want to use the bridges, which are interesting. But then again, you already use the products anyway.
Yeah, but I guess they just want to be able to spend time there, so being paid for that, it's a good excuse, even with regardless of the version used. Okay, I still don't see any question. So I guess we can go for again a virtual round of applause for Thomas. Thanks again. You have all the contacts there, so thanks for the presentation.
Thank you.
Okay. And now, this was the last presentation of this room. But the Academy is not finished yet. We have still 80 minutes of Academy, more or less. Just move everyone to the other room, the room number 1. Thanks for attending here in this room. Thanks for all the speakers, and thanks for all the other volunteers who helped behind the scene. And have a still nice, good, great Academy. Bye-bye.